Alright, so let's start with question number 1. A block of mass 200 kg is pulled along a rough horizontal ground at a constant speed of v meter per second by a horizontal rope attached to a winch. The coefficient of friction between the block and the ground is 0.8. The winch is working at a constant rate of 4000 watt. Find the value of V. Alright, for these sort of questions and for every question in mechanics, what you would like to do is to draw a rough sketch. So we have a rough horizontal ground, we have a block of mass 200 kg. So make sure that you label everything. We take G as 10 by the way in mechanics, so the weight is going to be mg, which is 200 times 10, which is 2000 newtons. Okay, and by the way we have a winch, so let me draw it a bit smaller. Okay, and it is attached by a rope. Okay, so it's the rope that is pulling it. All right, what else? We have been given the coefficient of friction. So, and the question says it is a rough horizontal ground. So whenever it's a rough surface, there is friction. When it's smooth, you don't have friction. So friction is basically the coefficient of friction times the normal reaction, which is basically R. Okay, so R over here is basically equal to the weight because the object isn't moving in the y-axis. Okay, it isn't moving up or down, it is just moving horizontally. So meaning that the net resultant force in the y direction is 0, which implies that the upward force is equal to the downward force, so it's just 2000. Okay, and we have been given the coefficient of friction is 0.8 times 2000, which is equal to 1600 Newton. Okay, so the friction acts over here, F, okay, small f, which is 1600 Newtons. Okay, tension always acts away from the object. Okay, now for the block it acts away, for the winch it also acts away, so you notice that, yeah. And the winch is working at a constant rate of 4000 watts. Alright, and we have been given that it travels at a constant speed. Okay, constant speed. So is there any formula to which we can link driving force, power and the speed? Yes, there is. It is P is equal to driving force times V. Okay, from here the driving force is equal to P over V, which is the power is 4000 watts. V is what we have to find. Okay, so we can just write it like that. Driving force, which is equal to 4000 over V. Okay, let's keep this aside. Okay, now let's focus on this point again, that it travels at a constant speed. Now what does constant speed mean? Okay, let's understand this. Constant speed means acceleration is equal to 0, and if acceleration is equal to 0, then the resultant force must be 0. So the forces on the left is equal to the force on the right. Okay, So first of all, immediately, let's start from this side, okay? Let's start from this side because we already know that friction is 1600 Newton. So what immediately comes on the right hand side? It's the tension. So first of all, we can say that friction is equal to tension, which is equal to 1600 Newton. Now, looking at the winch, there's a tension to the left hand side, okay, which is 1600 Newton, and there's a driving force, okay. So 1600 is equal to 4000 over V. V is equal to 4000 over 1600, which is equal to 2.5 meter per second. That's it for this question. Easy 4 marks. Alright, so question number 2. A cyclist starts from rest and moves in a straight line with acceleration 0.5 meter per second squared for 10 seconds. Blah blah blah. Okay, I'm not gonna read all of it. Okay, so right from here I know that it's a kinematics question. Okay, let me draw it properly. Draw a rough sketch again. A rough sketch, a rough sketch, a rough sketch. Okay, rough diagrams are going to be very useful and they are very important in AS math. Okay, now this is a VT graph. Now you might be thinking, why VT, why not AT graph? AT means acceleration time graph, why not displacement time graph? So the reason is the givens in the question. Okay, they gave you acceleration, they gave you distance, and they gave you information about time and velocity. Okay, obviously. So four of the givens are given to you. Okay, now velocity, it's given on the y-axis, okay, in a VT graph. Okay, so what about time? It's on the x-axis, so two of the givens are found easily. Now distance, this is the area under the graph. Okay, so we are done with distance also. Acceleration, this is the gradient of the VT graph. Okay, so you should keep those things in mind. Okay, now let's read it. Okay, let's skim through it. Let's take the main points. It starts from rest, moves in a straight line with acceleration 0.5 for 10 seconds. Okay, basically it accelerates. Okay, the acceleration is 0.5 meter per second squared. The time taken was 10 seconds, and the final velocity, they never mentioned it, so let's just give it a name, v1. Okay, v1. Now the next phase, they then accelerate at 1.5 for distance of 13 meters, reaching a speed of v. Now again they accelerate, but with a greater magnitude of acceleration, which means greater slope. Okay, now it's not really important to make it accurate, it's just that if you can do it, so why not? Okay, and 13 meters, okay, the distance was 13 meters, I've labeled that, reaching a speed of v. Okay, so reaching a speed of v, actually v is already, okay, let me write it again. Okay, let me write it again, v. Okay, the time wasn't given, it's okay. Okay, no need to worry, unless we need it we will find it later on. Okay, now they can travel at speed of v meter per second for 5 seconds. Okay, it travels at v meter per second for 5 seconds. Okay, now we know that this thingy is 5. Okay, I've labeled it 5 seconds. Okay, Okay, after that, they then travel at distance of 28 meter while decelerating uniformly to rest. Okay, just bring it down. It comes to rest. Okay, and the distance 28 meter. Okay, I don't have space, so I've labeled it like that. Alright, perfect. Now part A. Find the value of V. So they want this, okay? Value of V. So for that, let's find V1 first. V1, okay, is equal to U plus AT. You should know this by now, okay? So it starts from rest, U is 0, plus acceleration is 0 0.5, the time was 10. So this gives you 5 meter per second, okay? Now, they don't want V1, they want V. So, from here, we can find V, okay? We can find V. Now, by the way, we forgot to mention that A is 1.5 over here, okay? Now, A is 1.5 over there. We have initial velocity which is going to be v1 now, not 0, okay? Because we are considering this part, okay? This part only. Before we considered this part, now we are considering that part, okay? So I'm going to erase that. Okay, so we have final velocity which we have to find, acceleration, but we don't have time for that, okay? So okay, let's use the time independent equation because we don't have time, okay? So 2as is equal to v squared minus u squared. Okay, now what do we have to find? We have to find final velocity, which is radical 2as plus u squared. Now just plug in the values. 2 times 1.5 now, okay, not 0 0.5. The distance was 13 plus the initial is v1, which is 5 squared, okay? Now this gives you 8 meters per second, okay? Now part B, I find the total distance traveled by a cyclist. Total distance, okay? So this is pretty easy. Distance is nothing but area under VT graph, okay? So that's why it's really good to draw a rough sketch, okay? Now let's label this as area 1 and this as area 3. Now the good thing is they gave you, like, let me call this area 2, okay, which is 13 meter, and area 4, the last phase, which is 28 meters. So we just have to find area 1 and area 3. Area 1 is a triangle, so it's half into base times height. So half, the base is 10, the height is v1, which is 5. So this gives you 25 meters, okay? Now area 3. Area 3 is simply a rectangle, so length into width, okay? So the base is 5, okay? And the height is we found out it is 8, so 40 meters. Now distance total, you just add them up, okay? Add all of them up, not just area 1 and area 3. Okay, so area 1 was 25, the next up is 13 meters, it was already given, okay? Area 3 we found out it is 40, the last phase was 28. Now let me plug this into the calculator. 25 plus 13 plus 40 plus 28, this gives us 106 meter, okay? So you see how easy it is once you know the graph, okay? So part 2, find the average speed of the cyclist for the whole of their motion. Now again, average speed is nothing but total distance divided by total time taken. Okay, now total distance, the examiner is being kind to us, we already found that. Okay, now total time, this is where it gets tricky. Okay, total time, we have to find the total time taken. Okay, total time taken, we have to find that. And okay, let's start with the last phase. Okay, last phase. So over there, let's start. Okay, let's start from there. So we know that the final velocity is 0, initial velocity is v, which is 8. Acceleration, we don't have acceleration, they gave you the distance, so we can use s is equal to ut plus half at squared also, but I prefer, let's find the acceleration first, the deceleration. Okay, 2as is equal to v squared minus u squared, so a is equal to v squared, which is 0 squared minus 8 squared. I hope you understand this. Okay, so that's why I'm going quickly through it. The distance was 28 meters. I'm doing this for the last part. Okay, so what you get is minus 8 over 7 meters per second squared. Okay, now we can find it. Now we can find it. T, let me say T4. Okay, T4. It is V minus U over A. V was 0, U was 8. Yeah, acceleration, we just found it, minus 8 over 7. This gives you 7.0 second. Okay, now that's it. No, we found this to be, okay, we found this to be 7 seconds, but let me not write that. Okay, let me not write that over there, because in case you guys are viewing it later in the document, you might get confused, so leave let's leave it like that. Okay, now we need the time over here for this part of the journey. Okay, what's that? So I think we can find it. We have final velocity, we have initial velocity, and acceleration is there, so yeah, we can find it easily. What is that? T2, I guess. Okay, T2 is, final velocity was 8, initial velocity was 5 over 1.5, so 8 minus 5 is 3 over 1.5, which is just 2 seconds. Okay, so what is T total? T total is 10 plus 2 plus 5 plus 7. 12 plus 5 is 17. 17 plus 7 is 24. Okay, 24 seconds. Now average speed, let's write it as v. Okay, okay, this is the total distance, which we found out to be 106, over the total time taken, which is 24. Okay, now what do you get? Okay, so to three significant figures, this is 4.42 meters per second. Alright, that's it for question number 2. Alright, question number 3. Coplanar forces of magnitudes F Newton, 2F Newton, and 20 Newton act at a point as shown in the diagram. Given that the forces are in equilibrium, find the value of F and the value of theta. Okay, we have a force of F newtons acting vertically downwards, but the other two forces act at an angle of theta or 30 degrees. Okay, so we have to resolve them. Okay, so first of all, let's resolve the 20 Newton. Okay, the 20 Newton force. Now this is going to be 20 cos theta and this is going to be 20 sine theta. Okay, these are basic stuff, you should know this. Let me write a note. Okay, trick. Okay, component adjacent to theta is x cos theta. Okay, component opposite to theta is x sine theta. Okay, these are basic stuff, you should know this by now. Okay, now the same over here for the 2F Newton force. Okay, now this is going to be 2F cos 30, this is going to be 2F sine 30 because it is opposite to the angle. See it's opposite here. So I hope you get it. Okay, now it's in equilibrium. What does this mean? This means that F up is equal to F down. Okay, the forces upwards is equal to the forces acting downwards. Okay, so upwards we have 20 sine theta, which is equal to 2F sine 30, the downward forces, plus F Newton. Okay, yes. Now can we simplify this? Yes, we can. 20 sine theta is equal to 2 sine 30. Sine 30 is half, so it's just F plus F, which is 2F. Okay, now F left is equal to F right, the forces acting on the x-axis. Okay, so this is basically going to be 2F cos 30 is equal to 20 cos theta. Okay, so let me write it like this: 20 cos theta is equal to 2F cos 30. Now you might be thinking, why did I write like that? Okay, now to make it simpler, okay, this is equation number 1. Okay, this is equation number 2. We have to find F and theta from here. Okay, now what I would like you to do is divide 1 by 2. Okay, now you will see why. This is a shortcut method. Okay, 20 sine theta implies, okay, 20 sine theta over 20 cos theta is equal to 2F over 2F cos 30. I haven't done anything complicated. Okay, I just wrote the first equation, I wrote the second equation, and I just divided them. Okay, the equation number 1 divided by equation number 2. Okay, so 20 and 20 cancels out, 2F and 2F cancels out, so this implies that sine theta over cos theta gives you tan theta. Tan theta is equal to 1 over cos 30. Okay, what is that? 1 over cos 30 is 2 root 3 over 3. Okay, now theta over here is tan inverse of 2 root 3 over 3. Now what does that give you? This gives you theta as 49.1 degrees. Okay, now from here we can use any one of the equations. Okay, I will use equation number 1 because it just seems easier. Okay, so F is going to be 20 sine theta over 2. Okay, now just substitute the value of theta. Okay, now what I get is F is equal to 7.56 Newton to 3 significant figure. Okay. Alright, question number 4. Now, this question seems to me very long, okay? So, I'm not gonna read everything. Let's move on to the main thing, okay? The main thing is this, okay? Use an energy method to find the work done by the braking force as the car moves from A to B. Okay, you know what? We obviously have to read it, okay? So, let's read it step by step, okay? A car of mass 1600 kg. Let's skim through it, okay? Points A and B, speed 10, 12 respectively. Okay, distance AB is 2 kilometer. The heights of A and B above sea level are 250 meter and 200 meter respectively. Okay, now let's draw this. Every time draw a rough sketch, and this is going to help you a lot. So this is the sea level, okay? Sea level. Okay, the heights of A and B above sea level are 250 and 200 meter respectively. Okay, so A, this is A, okay, this is 250 meters. Okay, now B, this is B, okay, this thing over here is 200 meter. Okay, this is B, and they told us the distance AB is 2 kilometer. This thing over here is 2 kilometers. Okay, the car engine does no work in moving from A to B. There are two forces resisting the motion of the car: a braking force, an additional constant force of magnitude 150 newtons. Okay, so keep a note of that. And by the way, at point A, the speed of the car is u is equal to 10 meter per second, and at B, v is equal to 12 meter per second. Okay, I wrote u because that's the initial speed, and b because that's the final speed, okay, because it moves from A to B. Okay, and by the way, we can also find the AB vertical height. What's that gonna be? 250 minus 200, which is 50 meters. All right, now use an energy method to find the work done by the braking force as the car moves from A to B. There are two resistive forces. One is the constant force of magnitude 150 Newton, and the other is a braking force. Okay, so whenever an object moves down, okay, down a plane or whatever, you're losing GPE. So loss of gravitational potential energy, okay, sorry for the slip of the tongue, loss of GPE is equal to gain in kinetic energy, because the speed increases, so there's a gain in kinetic energy plus work done against resistance. Work done against resistance. Okay, so keep a note of that. Loss of GPE, what is that gonna be? It moves from A to B. Okay, so the mass is 1600, because this is mgh. Okay, mgh, and this is half mv squared. Okay, 1600, g is 10, and the height is going to be 50 meters. Okay, because from A to B the vertical height is 50 meters. Okay, so 50. Gain in kinetic energy, so half into m, which is 1600, final speed squared minus initial speed squared. Okay, so 12 squared minus 10 squared. Okay, plus work done against resistance. Okay, so first of all, the 150 Newton, and it moves 2 kilometers. Okay, the distance is 2 kilometers. For frictional forces, you always use the original one. Okay, you don't use the vertical height. That's for GPE. Okay, for kinetic energy or like friction, kinetic energy, you don't need the distance. Okay, but for frictional forces, you use the distance parallel to it. Okay, the actual one. so which is 2 kilometers, so it's 2000 meter, okay, plus the braking force. Okay, we can just write the work done by the braking force, okay, work by braking force BF, okay. Let me write it like that. We can find the braking force, but no need, because they just want the work done by the braking force, okay. So 1600 times 10 times 50, this is going to give me 8 times 10 to the power of 5 joules, okay, but no need to write that right now, okay. Then half into 1600 times 12 squared minus 10 squared, okay, what does that give me? 35,200 plus 150 times 2000, that gives me 3 times 10 to the power of 5 plus WBF, okay. I'm going to write it in short form. Now what is WBF? It is, just move everything to the left hand side, okay. 8 times 10 to the power of 5 minus 35,200 minus 3 times 10 to the power of 5. Let me plug this into my calculator. Minus this gives you 464,800 joules, okay. So that's it for question number 4. Alright, so question number 5. Again, this is a very lengthy question. I'm not gonna read it again, but we already have the key information given on the diagram, okay? So they just repeated all the stuff. Okay, just one thing to keep in mind is the coefficient of friction between each of the particles and the plane is 0.4. So it means that it is a rough plane, okay? There's friction, and obviously each of the particle experiences the friction, okay. P also experiences friction, and so does Q, okay. Part A, find the magnitude of acceleration of the particles and the tension in the string. So first of all, let me sort of label all the forces for P, okay, for P, and we'll do the same for Q. Okay, let me make it better, okay, yeah. So Q, and that was for P, okay. So for P, this is 0.3 kg, okay. So first of all, the weight, we have to resolve it into its components, okay. Now as I said earlier, this is 30 degrees, so this is going to be, by the way, 0.3 times 10, the weight is going to be 3 newtons. So I just immediately wrote it, okay. So this is going to be 3 cos 30, this is going to be 3 sine 30, okay, and it acts downwards, okay. And now what else? There's tension, okay, tension acting away from the object, okay, away from the particle, and friction. Now friction P is equal to mu times rp. Now 0.4 times, what is going to be r? The normal reaction force, okay. So r is nothing but just equal to the vertical component of the weight, which is 3 cos 30. Let me put this into my calculator. 3 cos 30 times 0.4, this gives you 3 root 3 over 5, okay. Now same thing for Q. For Q, we have a 12 Newton force over here, okay, 12 Newton force. Now then let's resolve the weight, okay. So this is 30 degrees, okay, this is going to be 2 cos 30, this is going to be opposite, so 2 sine 30, okay. Now what else? We have tension away from the object over here, but this time tension acts leftwards, okay, down the plane. And friction always opposes the motion is upwards, so there is friction downwards, okay. I forgot to label friction for P, okay, this is friction. Now friction Q is equal to nu times RQ. Okay, so 0.4 into what is RQ? RQ is the vertical component of the weight. Okay, so it is 2 cos 30. So 0.4 times 2 cos 30, this gives me 2 root 3 over 5. Okay, now the motion is upwards, so let's construct two equations. Okay, two separate equations for P first of all. Okay, for P this gives me, what does this give me? The upward force T minus the backward forces, which are the friction, which is, let's write the values straight away. Okay, we don't have to waste time. 3 root 3 over 5 minus, don't forget this one. Okay, don't forget this one, minus 3 sine 30. Let's just write it. Okay, it's 1.5, but let's just write it so you guys don't get confused, which is equal to m times a. So the mass of P, which was 0.3 into a. Okay, yes, that's it. Now for q, for q for q the upward force is 12 minus the backward forces. We have three forces. Okay, minus tension minus the frictional force, which is 2 root 3 over 5. Okay, and minus 2 sine 30, which is just 1. Let me write it again because some of you might get confused. 2 sine 30 is equal to mq times am. What is the mass of q? It's 0.2 into a. Now just add p plus q. Okay, p plus q. Okay, now why do we add it? Now the reason is, you will see now. Okay, t and t cancels out, so we can find a easily. Okay, that's the trick over here. So this is just 12 minus 3 root 3, okay, over 5. I'm doing it on my calculator directly. Minus 2, okay, minus 2 root 3 over 5 minus 1.5 minus 1. So on the left hand side, what I get is 19 minus 2 root 3 over 2 is equal to 0.5a. Okay, why 0.5? Because I added 0.3 plus 0.2. Now this implies that a is equal to, just divide that by 0.5, and you will get that your acceleration is 15.5 meters per second squared. Now what about the tension? You can use any one of the equation. Okay, you could use P or Q, and by the way we have to find T. Okay, so just substitute it. Okay, so I don't have enough space, I hope you get it, but let me just try. Okay, so you guys don't get confused. 0.3 into, I'm using equation P. Okay, 15.5 plus what, plus 1.5, you move it to the other side. Okay, plus 3 root 3 over 5. Now what does this give you? Okay, let me sort of separate this. Okay, 0.3 into 15.5 plus 1.5 plus 3 root 3 over 5. This gives me that tension is 7.19 newtons. Okay, to three significant figures. Now part B. At the instant when the speed is 2 meter per second, the string breaks. Find the time it takes from the instant the string breaks until P comes to instantaneous rest. Okay, so now what they said is, we have the diagram P. Yeah, we have it. Let's just draw it again. Okay, so you guys understand it. This is P. Okay, now again the weight. Okay, this is going to be 3 cos 30, this is going to be 3 sine 30. Okay, there's a frictional force. What was the magnitude? It was 3 root 3 over 5. Okay, And but now we don't have the tension. Why? There is no tension. There is no tension as the string breaks. Okay, so note this. This is the key point. Okay, so there's no tension. Before we had tension, now we don't have tension. Now we have to find a new acceleration. The acceleration we found for P and Q was the combined acceleration of the system. Okay, so it's the same for P and Q. But now the string broke. Okay, the rope or string, whatever. Yeah, string. Okay, so anyways, either ways, I hope you get the point. Okay, so there's no tension this time. But the thing to keep in mind is it won't just immediately go down. It's going to go up. It comes to instantaneous rest and then it changes the direction because it can never just go back immediately. Okay, it has to come to a point where its velocity becomes zero and then it changes its direction. Okay, so I hope you get the point. So the new acceleration is going to be, there's no force upward. Okay, so nothing minus 3 root 3 over 5 minus 3 sine 30 is just 1.5. Okay, I just wrote it directly. Okay, and implies, okay, ma. So what is the mass? 0.3 a. Now from here acceleration is, just plug this into your calculator. Okay, minus 3 root 3 over 5 minus 1.5 divided by 0.3. You will get that your new acceleration is minus 5 minus 2 root 3. Okay, keep it in exact form. Okay, so you'll get a more accurate answer. Now we have been given that the initial velocity is 2 meter per second. Okay, and as I said, for it to change direction, and anyways they said it comes to instantaneous rest. Okay, so instantaneous rest means v is equal to 0. It goes up. Okay, it continues its direction of motion. It comes to a point where its velocity becomes 0 and we found that we have an acceleration. Okay, I will just put an arrow. Okay, so time taken is v minus u over a. So v is 0, initial velocity is 2 over minus 5 minus 2 root 3. So this will give you a really good and accurate answer. Okay, so you will get that the time taken is 0.236 seconds. That's it for this question. Question number 6. Two particles P and Q of masses 4 mkg and 3 mkg respectively are at rest on a smooth horizontal ground. So there is no friction. P is projected directly towards Q with speed 6.5 meter per second. After the particles collide, they move in the same direction and the speeds of P and Q are 2 meter per second and v meter per second respectively. Part AI showed that v is equal to 6. Again, draw a rough sketch. This is gonna help you a lot. Okay, so this is P. P is equal to 4m. Okay, and there is Q. Q is equal to 3m. Okay, they are initially at rest, but then P is projected with a speed of 6.5. Okay, 6.5 meters per second. Okay, after the particles collide, they move in the same direction and the speeds of P and Q are 2 meter per second and v meter per second respectively. Okay, this is before. Now what about the after? After collision, P, which is 4m, moves at speed 2 meters per second, whereas Q is 3m and it moves at speed v. Okay, after they move in the same direction, so that's why I pointed the arrows in the same direction. Okay, Okay, so we have to use law of conservation of momentum. No need to write this, by the way, in the exam, but it's just good so the examiner knows that you know the concepts. Okay, law of conservation of momentum, YD. Okay, so 4m into 6.5, q is at rest, so 0 is equal to 4m into 2 plus 3m into v. Okay, we can cancel out the m's. Okay, it's everywhere, so we can just cancel it out. So what is v? V is equal to 4 into 6.5 minus 4 times 2, which is 8. Okay, over 3. Now what does this give me? Let me check it out. Minus 8 over 3. This gives you that v is equal to 6 meters per second. So they told us that show that v is equal to 6. So hence v is equal to 6 meters per second. Okay. Okay, part 2. Given that the energy lost in the collision between P and Q is 45 joules, find the value of M. Okay, so the energy loss. So kinetic energy initial, first of all. Let's find that. So that's going to be half into the mass, which is 4m, into 6.5 squared. We are looking at initial, so the before. Okay, and q just doesn't have any kinetic energy, it's at rest. So 0.5 times 4 times 6.5 squared, this gives me that kinetic energy initial is 84.5 m. Now what about kinetic energy final? Kinetic energy final is equal to half. Now we look at the after. Okay, so 4m into 2 squared plus half into 3m into v was 6. Yeah, so 6 squared. Okay, so 0.5 times 4 times 4 plus 0.5 times 3 times 36. This gives me 62m. Okay, now the energy lost is kinetic energy initial minus kinetic energy final. Okay, so remember this. So 84.5 m minus 62m is equal to 45. Okay, so what is that? 84.5 minus 62, 22.5 m is equal to 45, so m is equal to 2 kg. Okay, so easy and simple. Alright, after Q has moved a distance of 9 meters from the point at which P and Q first collided, it hits a vertical wall perpendicular to the direction of motion of Q and rebounds. The speed of Q after hitting the wall is 0.5 meters per second. Part B. Find the distance from the wall to the point at which the second collision between P and Q occurs. Okay, so just imagine what happens. Okay, draw a rough sketch again. This is going to help you a lot. Okay, so you need to understand what's happening. So this was the first collision. Okay, first collision. Okay, this is P, this is Q. Okay, and any other info. The after they move at P moves at 2 and Q moves at 6 meters per second. Okay, so P moves at 2 meters per second and Q moves at 6 meters per second. And after Q has moved a distance of 9 meters from the point at which P and Q first go, it hits a wall. Okay, so basically they're indirectly trying to say that this distance is 9 meters. Okay, the distance between the wall and Q is 9 meters. Okay, so they want the distance from the wall to the point at which the second collision between P and Q occurs. Okay, so what's happening? Q goes and collides with the wall and then it rebounds, okay? So this is Q. Let me draw it. By the way, by rebound, it should be here, yeah? This is Q. And it moves at 0.5 meters per second, okay? This is what is happening, okay? So then P moves, okay? P is still moving over there and they collide again. So they want the distance from the wall at the point with which the second collision happens, okay? So first for that, we have to find the time taken for Q to collide with the wall, okay? What's that gonna be? There's no acceleration, okay? So it's just going to be time is distance over speed, okay, which is 9 over 6, which is 1.5 seconds, okay. Now during this time, P also has a velocity, a speed of 2 meter per second, so it's not gonna stay at that same position. It's gonna move a certain distance, okay. So we have to find that distance, okay. Distance traveled by P, okay, is also gonna move. So D is Vt, okay. So its velocity is 2 and the time is 1.5, okay. So that's going to be 3 meters, okay. So P travels 3 meters, okay, 3 meters, and the remaining what is left is, okay, so let me use a different color. Let me use purple, okay. So P is over here right now. This is where P is, okay. P is, and it has to travel 6 meters now, and Q is over here, okay. It has rebounded at this point, okay. So let's find the time taken for second collision between P and Q, okay. Now for that, time is equal to distance PQ over relative speed, okay. The relative speed, you have to take that into consideration. So the distance PQ is 6 meters as we found it, okay. Why am I writing M over there, okay? That's the unit. So 6 over the relative speed, okay. By the way, I did not label that on the diagram. It still moves at speed of 2 meter per second, okay. So whenever two objects move towards each other, okay, so the relative speeds add up, okay. So keep that in mind. So 2 plus 0.5, okay, 6 over 2.5, basically 6 over 2.5, that gives me 2.4 seconds, okay. So 2.4 seconds, that's the time taken for second collision. Now we can find the distance from wall. It's easier to use Q because Q is already like next to the wall, okay. So we can find it using Q. You can also find it using P, okay. So I will use Q because it's already relative to the wall, okay. So it's Vt, okay. So what is the speed of Q? It is 0.5 meter per second, and the time taken for second collision is 2.4. So this gives me 1.2 meters, okay. So this is your final answer, okay. Now if someone, for example, uses P, I don't want to use Q, how would he do it, okay. So if you use P, I'm not going to write that, but let me just give you an idea, okay. So we found that the time taken for second collision is 2.4. So from this point onwards, you find the distance it travels. Okay, 2 times 2.4, it gives you 4.8. So P comes over here, it travels 4.8 again. So 6 minus 4.8 is gonna give you 1.2 again, 1.2 meters away from the wall. So that's how you solve this. Okay, so I guess it's kind of complicated, but you need to know how to solve these type of questions. All right, so question number 7. Particle P travels in a straight line. The velocity of P at time t second is v meter per second, where v is equal to blah blah blah. Part A. Find the acceleration of P at time t equal to 4. So acceleration is the derivative of velocity. Okay, so you derive the equation, you will get that derivative of t is just 1 minus 7 times the power, which is half, times t, and you reduce the power by 1, so half minus 1 just becomes minus half, and derivative of a constant 12 is just 0. Okay, now a at t is equal to 4 is equal to 1 minus 7 times half times 4 to the power of minus half. Now let's plug this into the calculator. Times 0.5 times 4 to the power of minus 0.5. This gives you minus 3 over 4 meter per second squared. Alright. Now part B. Find the values of t at which p is instantaneously at rest. Okay. So what does that mean? You just put v is equal to 0. Alright, so t minus 7 t to the power of half plus 12 equal to 0. Now notice that we can turn this equation into a quadratic and easily solve it. Okay, so let's take a term or variable x. Okay, so let t equal to x squared. So that means that t to the power of half becomes x. Okay, so this becomes a quadratic now. Okay, x squared minus 7x plus 12 equal to 0. Now if you factor this, okay, this gives you x squared minus, let me do it step by step. Okay, so x squared minus 3x minus 4x plus 12 equal to 0, x into x minus 3 minus 4 into x minus 3 equal to 0. So this gives that x minus 3 into x minus 4 equal to 0, x is equal to 3, or x is equal to 4. Now coming back, t is equal to x squared. Okay, remember this. So t is equal to 3 squared, which is equal to 9 seconds, and t is equal to x is equal to 4, so 4 squared, which is equal to 16 seconds. All right, that's it. Now part C. Find the total distance traveled by P in the interval 0 to 25. Okay, and notice that it's a 5 marker. Okay, so you can't just simply integrate it from 0 to 25. Okay, because distance, d, or displacement, whatever you want to call it, it's the integral of v. Okay, v with respect to dt. So this is integral of, write the equation, t minus 7 t to the power of half plus 12 dt. Okay, so this gives us, integrate this, t squared over 2 minus 7t, you add 1 to the power, so it becomes 3 over 2, divide by the power, all right, plus 12t. Okay, Now I won't put the constant of integration. Alright, let's just put it as of now, okay? But you won't need the constant of integration. So this gives us t squared over 2 minus 14 over 3 t to the power of 3 over 2 plus 12t plus c. You won't need the constant of integration because we are going to put the limits, the boundaries, okay? Now, they have actually helped you out because in part B we have found that the velocity becomes 0 at t is equal to 9 and t is equal to 16 seconds. And whenever velocity is 0, let me write this, okay? Whenever v becomes 0, direction of motion is likely to change, okay? And they also said instantaneously, so most likely it's gonna change, okay? Now, so what I mean is distance is, we found that, yeah, so t squared over 2 minus 14 over 3 t to the power of 3 over 2 plus 12t. So that's why I said you don't need constant of integration when there are limits, okay? So now you have to plug this from 0 to 9, then t squared minus 14 over 3, okay, t to the power of 3 over 2 plus 12t. Now you have to add this with from 9 to 16, okay? You take three separate boundaries, okay? And then t squared over 2 minus 14 over 3, t to the power of 3 over 2 plus 12t from 16 to 25, okay? So that's the main idea. And by the way, take the absolute value, or whenever you get negative you could just take the absolute value, but it's just safer, okay? Just put absolute value for everything, okay? So this would save you time when you plug it into your calculator, okay? So you don't have to worry about the negative sign, it's just already been taken into account, okay? It becomes positive automatically. Whenever there's distance, if they say displacement, then you should not take the absolute value, okay? So I don't have enough space, okay? So by the way, this is the main idea, okay? So anyways, you're gonna get that for the first, it's gonna be 22.5. For the second part you're gonna get 7 over 6, I guess, yes. And for the third part you're gonna get 47 by 3, and when you add them all up you'll get 31.5 meters. All right, so that's it.